In this video, we will work out numbers 7 through 35 every other odd of section 3.1 in MA 104. For number 7, we are asked to determine if the table defines a function. A function is a relation in which every element of the domain is paired with exactly one element of the range. So our domain elements are given to be -1, 0, and 1. The domain element of -1 is paired with 3. It's not paired with anything else. 0 is paired with 2. Again, not paired with anything else. 1 is paired with 1, not paired with anything else. Since each one of these elements is paired with exactly one element of the range, then this is a function. Next, instead of numbers, we're given subjects, school subjects, as elements of our domain. English, math, sociology, and chemistry. This looks like a report card in which the subjects are the elements of the domain, and then the grades are the elements of the range. In this particular table, the domain element of English is paired with an A. It's not paired with anything else. Math is paired with a B. Again, not paired with anything else. Sociology goes with an A, nothing else. Chemistry with a B, nothing else. Since each element of the domain is paired with exactly one element of the range, this too is a function. It's okay that the elements of the range repeat as long as the elements of the domain do not. In this example, we have to indicate whether the set defines a function and then find the domain and the range. Well, if we look, our domain elements are all of the x coordinates. So if you look, we would go through each one of these ordered pairs and find the x coordinates. My domain elements then are 10, 5, 0, and then the last 2 points would be 5 and 10, but I already have those listed, so I do not need to list them again. My range elements are the set of all of the y coordinates, or all of those second coordinates. So when I list the range, that would be -10, -5, 0, 5, and 10. You can see in this example that some of the elements of the domain are paired with more than one element of the range. In other words, the domain element of 10. 10 is paired with -10, but 10 is also paired with +10. Same thing with 5. 5 is paired with -5. It's also paired with +5. Because those elements of the domain repeat, or because they are paired with more than one element of the range, this relation is not a function. In this example, we're given the graph and asked to determine whether the graph is the graph of a function. When we look, we're looking to see if it passes the vertical line test. In other words, if I draw a vertical line anywhere that crosses this graph, will it hit at most one point? It can't hit more than one point. Well, if I look in this case, anywhere I would construct a vertical line, the most I'm going to hit is 1 point on that graph. There's no way to hit more than 1 point on that graph. Because of this, the graph passes the vertical line test and is the graph of a function. When we look at this point, or this line, this is a vertical line, so it fails the vertical line test pretty substantially. I can draw a vertical line straight through here so that it hits every point on the graph, which is definitely more than one. So this graph is not a function. In this example, we're given the function f of x is equal to 3x minus 5, and then we're asked to find several different values of the function at particular values of the domain. So to start, for part A, we're asked to find f of 3. In other words, what's the value of the function f when the domain value is 3? I would go back to my function, which is 3x minus 5. Anywhere I see an x, I'll plug in the 3, which gives me 9 minus 5, which is 4. So that tells me that f of 3, I'll use a better color there, f of 3 equals 4. Next, I'm asked to find f of h. Finding the value of a function at a variable is no different than finding it when you have a number in place of that domain value. For f of h, I'm still going to take out the x, I'm going to take out that domain value and replace it with, in this case, an h. So instead of saying 3 times x, I'll say 3 times h minus 5. There's no way to simplify this any further, so I know that f of h is 3h minus 5. For part C, I'm asked to find f of 3 plus f of h. Because I see that f twice, that means evaluating this function 2 different times, and then adding my answers together, or adding my results together. Well, I have to find f of 3, which I already did in part A. I have to find f of h, which I already did in part B. So to find f of 3 plus f of h, I'll simply take f of 3, which we know is equal to 4, and add that to f of h, which we found was 3h minus 5. Combining my like terms, I have 3h minus 1. And then finally for part D, I'm asked to find f of 3 plus h. In this case, I only see the f one time. That means I'm only evaluating the function one time. I'm replacing the domain variable x with this 3 plus h, this quantity 3 plus h. So instead of saying 3 times x, I'll say 3 times the quantity 3 plus h, and then I still have the minus 5. If I distribute the 3, that gives me 9 plus 3h minus 5. If I combine those like terms, I have 3h plus 4. In this problem, the function that I'm given is f of t equals 2 minus 3t squared. I'm first asked to find f of negative 2. So that simply means replacing every place I see a t, filling it in with negative 2, which gives me 2 minus 3 times negative 2 squared. Order of operations says that I do the exponents first, so this gives me 2 minus 3 times negative 2 squared, which is positive 4. Next, I would have to do the multiplication. So I have 2 minus 3 times 4, which is 12, which altogether gives me negative 10. So I know that f of negative 2 is equal to negative 10. For part B, I'm asked to find f of the opposite of t. So this one's a little bit different. Instead of plugging in a t, I want to plug in the opposite of t, which I can also think of as negative 1 times t. So that gives me 2 minus 3 times the opposite of t squared. Well, again, I would do those exponents first. So I have 2 minus 3 times the opposite of t squared. You can think about that a couple different ways, but ultimately it's anything multiplied by itself. So I have the opposite of t times the opposite of t. That's kind of like negative 1 times t times negative 1 times t. And a negative 1 times a negative 1 is a positive 1, and t times t is t squared. Another way you can think about this is anytime you square a negative number, you're going to get a positive. So this ends up being 2 minus 3t squared, which is the same as the function that we started with, but the point is that you get back the same thing that you started with when you plug in that opposite of t. Part C is a little bit different. With part C, we're asked to take the opposite of the entire function. So in other words, it's like taking that original function and multiplying it by a negative 1. So if I want to find the opposite of f of t, that means finding the opposite of that quantity, 2 minus 3t squared. So I just want to change the sign of every term. That ends up giving me negative 2 plus 3t squared. Every sign got changed. Finally, for part D, to take the opposite of f of the opposite of t, well, again, that's taking the opposite sign of every term that makes up f of the opposite of t. But we found in part B that f of the opposite of t is just that 2 minus 3t squared. So when I fill this in, I'm going to be taking the opposite of 2 minus 3t squared, which ends up giving me the same thing as part C, which is negative 2 plus 3t squared. In number 35, we're asked to use this particular function, whose graph looks like this. The important thing to note before we get started here is this particular function, the scale goes by twos, so please be aware of that. Positive 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. So please just be aware that the scale is a little bit different. For part A, we're asked to find f of negative 2 to the nearest integer. Well, finding f of negative 2 means that we've replaced the x value, or the domain value, with negative 2. So what part A is really asking is for f of negative 2, when x is negative 2, what's the corresponding value of y? Well, if I find negative 2 on my x-axis, here's the coordinate for negative 2. All of these points along this vertical line are negative 2 comma something. I'm interested in the graph of this particular function, the coordinates for y when x is negative 2. Well, here are the points, or here is the point rather, for negative 2 comma something on the graph. If I take a closer look at what that point is, it's negative 2 comma 2, 4, 6. So f of negative 2 is just equal to 6. For part B, I'm asked to find all the values of x to the nearest integer so that f of x is negative 4. This time I am given f of x, which is y. In other words, this negative 4 would be the y coordinate. So I need to know all the values of x that make f of x equal to negative 4. In other words, where are the points that are something comma negative 4? If I find negative 4 on the y-axis, negative 2, negative 4, here's negative 4. All of these points along this horizontal line are something comma negative 4. So I just need to figure out what those x values are. In other words, here's a point that's something negative 4, here's a point that's something negative 4, here's a point that's something negative 4. So if I look, this point, negative 2 for about negative 6 comma negative 4, so x could be negative 6. This point is 2 comma negative 4, so x could be 2. And then this point is 2, 4 comma negative 4, so x could also be 4. So these values of x are all of the points on this graph that are something comma negative 4. We have negative 6, so we have the point negative 6, negative 4 on the graph. We have positive 2, so we have the point 2 comma negative 4 on the graph. And we have positive 4, so we have 4 comma negative 4 on the graph.